Greetings, fellow scholars. Welcome to Excel 3 Scenario 5, where we're going to talk about populations, samples, and probability. When we think about populations, our first thought is usually people. In this particular little clip art, we have a large group of people that represents our population, and then a little part of that group represents our sample. So when we take a sample correctly from a population, if we do our sampling certain ways, which we're going to talk about in this video, then this little group of sample people can actually give us ideas, thoughts, opinions, tell us about things they like, they want, things they care about, and we can take that information and project it onto the larger population if our sample is correctly and strategically chosen, or completely and totally randomly chosen. So let's take a look at what all of that means. Before we start talking about sampling, I wanted to show you guys that people are not the only types of populations we talk about when we talk about sampling. Here you see this beautiful conveyor belt. This is not a conveyor belt. This is a big warehouse where they make a lot of cars. Okay, I got the word I was looking for, an assembly line. So here we have a long assembly line of cars, and you can consider not just this assembly line, but all the cars that are made in this whole entire shop to be the population of the Teslas that we're talking about here. Now, what if I wanted to go take a sample of a bunch of crystals? If I'm out on Lake Washita, those of you here from Hot Springs, and I have entire islands covered in crystals. And what if I wanted to know about some of the crystals on that island? Well, I might take a sample of some of those crystals, perform some tests, and it might give me information that I can project onto the entire population of crystals on that particular island. So when we talk about populations and samples, you guys remember when you did your dice rolling and you realized that the more times you rolled the dice, the closer your probability, your empirical probability, became to the theoretical probability. Well, that's the same type of situation we deal with when we take a sample from the population. Our sample mean may not be the same as the population mean, but we're pretty confident that those means are within a couple standard deviations of where they're supposed to be, depending on the data that we're discussing. But what I want you to see by this little picture is that if we had a larger sample, then mathematically, the theory says that the more elements in our sample out of the population, that our sample mean would come closer to the population mean. So that's a lot like our law of large numbers that we looked at with our dice rolling. All right, so are you guys ready to talk about random sampling? We are going to look at random sampling, systematic sampling, stratified sampling, and cluster sampling, and we'll go through each of these as we get to them. These are the types of samplings that we can use to talk about probability. Remember when I discussed that if we sampled correctly, if we chose our sample correctly, we could project what we learn from that sample onto the larger population. So these are the basic sampling techniques that allow me to be able to do that. These are not all of them, but these are the basis of the ones that we usually look at. All right, so let's go down to random sampling. Now, there are many ways to take a random sample. Really, more importantly than ways to collect a random sample are ways that are not random that might seem random. I thought of all the ways to show you how to do random. We are going to do some random numbers in Excel, but I thought it would be fun to look at an old-fashioned random table of numbers. So before we had our random function in Excel, we had tables of random numbers. And in this particular case, we are going to, let's just say I have 72 employees. and I want to choose 10 employees to go to a professional development. I want to just randomly choose them, because if I strategically choose them, I'll just choose the employees I think most need to attend. But I need a nice random selection of my 10 employees so that I can get a better perspective. Some people who are interested and want to go, and then the other people who don't want to go at all. So I'm going to randomly choose these guys. So here are my instructions for this particular, and you could change these however you want to. Start on row 9, column 9, and choose 10 random numbers between 1 and 72. So I want to pretend that each of my employees has a number between 1 and 72, and I'm going to choose those guys. So starting on row 9, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, column 9. Well, these columns are clustered into fours to make it easy for us to count them. So there's 4, 8, 9. There we go. All right, so I'm looking for two-digit numbers. You see that I did have to make this 0, 1, not just a 1. It has to actually have all the same. If I were doing, just for example, real quick, let's say I had 720 employees, then my numbers here would have to be 001 to 720. All right, so you guys see how that works. Okay, so my first two-digit number that I collected here is 82. You guys see that 82 right there where my cross-reference is. My next number is 11. And then I have 29, and you guys can see how I did have to cross over the aisle there, and that's perfectly okay. That's how you have to do it. And then I have 69. Oh, and I forgot to discuss all the way back up here at 83. You guys see I had to cross that number off because it was too big. It's bigger than 72. So that does not count toward my 10 random numbers. Sorry, I left you hanging. Wasn't thinking about that. Hopefully you figured it out though. Okay, and then my next number is 97. Again, 97 is too big. So I just cross that one off and it does not count toward my 10. My next number here is 34. And then I have 08, so my next number is 8. And then I have my next number is 3, and so on until you get 10 random numbers, of course, not counting, in this particular case, the 97 or the 83. All right, you guys, now, just real quick before I get off this random number, what if I had said to start in row 9, column, I don't know, column 25, or let's say column 24. Let's go with 25. All right, so here I have 4, 8, 12, 16, 20. Here's row 9 is already marked with my horizontal highlight down there. And then 25 is going to be right here. And now okay, so let's say I'm going to start at that point. Now I'm going to grab my two numbers and I can just go down. So here my first number would be 2, 18, 49, 76, too big, throw it out, 10, 43. So when you guys are dealing with a random number table, a random table of numbers, you can do anything you want with this thing. So you can even Google videos. It's kind of fun. Playing a game with your kids, doing some stuff with random numbers might be fun. All right, so one way to choose random numbers. Now let's look at systematic. Talking about systematic made me think about the car dealership. So when I thought of systematic sampling, I thought about the reason I actually lost my wording on this is because I had originally thought about an assembly line, because I have a friend who's a statistician who actually works on an assembly line doing systematic sampling. All right, and a statistician, I think, is the correct way to say that. Hopefully, you guys can look it up for me. All right, so what is systematic sampling? Well, every nth element chosen started at random and picking every nth element. And you guys don't like the word nth element, so let's say every sixth element. Let's just change this nth to sixth. All right, so if we want to look at systematic, whoa, look, there's a Model Y. So I guess we're going to think about the Tesla Model Y assembly line, and we're going to think about test driving these guys. Yay, looks good to me. I didn't even notice the number 28 is right here on this car. That happens to be my favorite number. So we are going to test drive, lucky us, right? My lucky number or my favorite number. And we get to test drive every sixth Tesla Model Y that comes off that line. What do you guys think about that? So this is systematic sampling. I'm going to take every sixth Model Y, or I'm sorry, this is actually the Model X I'm looking at here. I can see now my clip art. So every sixth Model X is going to come off that line, and I'm going to get in that Model X, and I'm going to make sure that it drives fast enough. I'm going to make sure the seat belts work, that all the lights work, and everything's going well. So now that I have got a chance to test drive the Model X, I can see maybe they want me to test drive the Model S, the Model 3, the Model X, and the Model Y. Who knows? I can do some systematic sampling for Tesla. Maybe they'll let me, huh? All right, let's look at stratified sampling. Stratified sampling is a very good method of separating your information into, well, we have it right here. The population is divided into subpopulations or stratum, and stratum just means sections. And I can even just right click on the word stratum and go to synonyms, and I can see that the word section or branch, I can look at different layers. Okay, so that's all that word means. If you ever wanted to do that and you didn't know how, now you do. All right, and then I'm going to select each individual subject from my subpopulations or my sections. So let's see what that looks like. We're going to look at one of the most popular stratified sampling methods that I was able to find from Google, which was looking at the legislative partisan composition. This one particularly is from 2017. It was the best clip art I could find. We're going to look at Republicans, Independents, and Democrats because, again, that was the clip art that I found. All right, so let's have a look. We're going to actually classify or take subpopulations of the overall population. So let's say that our overall population is all Americans, and I want to know some stuff about these Americans. Well, what if I want to know about religious liberty, queer rights, abortion, immigration, environmental issues, or economic inequality? If I want to know about any of these issues, well, it's going to be better for me to section off the Americans into the different political parties because each party on average in general is going to give me probably a pretty similar answer in these very hot topics in politics. So let's have a look at just Arkansas. Let's use Arkansas to talk about stratifying our population. So let's say we want to know about some of those topics. We want to know about how people in Arkansas feel about some of these topics. Well, Arkansas, after a quick Google search, I was able to pretty easily see that we are separated about 60% Republican, about 3% Independent, and about 30% Democrat. So in this case, and these are all rounded up, but the first 5 things that came up in Google were pretty close to that. So just take it for what you will. This is now I am showing you the population of Arkansas is about 3.4 million, and 60% of Arkansas, which is about 2 million people, are Republican. About 0.1, so what, about a tenth of a million of the people are independent, and then about a million of the people are are Democrats. So let's see what it means to stratify this population. If I want to pull 25% of our entire state to find out how they feel about any one of these particular topics, how about if I want to know how Arkansas feels about queer rights? So that covers a lot of different types of people's rights, homosexuals, transgender people, and many other groups. So we want to know, how does Arkansas feel about that particular topic? Well, if I wanted to find that out, I would want to get a good representation of Arkansas. So if I just did a random poll of the state, I would have to be pretty careful, because I think you guys can probably clearly see that if I look at the mid to southwestern part of the state right here, that I would get a very, very different poll than I would if I looked over at mid to southwestern side of the state. So to get a very good gauge of how Arkansas feels about my hot topic, I would want to make sure that I got about some proportional number of representation from each party. So to do 25% of the population, it looks like I would have to try to poll about 500,000 Republicans, about 25,000 independents, and about 250,000 Democrats. So if I wanted to proportionally represent the state, this is about how many people I would have to pull from any of the particular parties. All right, well, let's look at just something you might see reported in the news. So in this case, I'm going to create a legend. And this legend is just going to tell me that one elephant here, one political elephant, represents 0.25 million people. One of these cool little icons represents 250,000 people. And one of these donkeys represents 2.5 times 10 to the fifth people. All right, so each one of these represents this many people. And I am kind of going off on a tangent here. A tangent is just kind of off the path. And I just kind of did this because I thought it was a cool way to remind you about scientific notation and notating things in different ways. So 2.5 million means 2.5 times a million, which gives me 250,000. 250,000, well, that is just, well, what it says, 250,000. And then our scientific notation, if you guys remember from scenario 1, module 1, is 2.5 times 10 to the fifth, which again is 250,000. So in the end, I was just making a short story long. So here you guys have your legend. Each one of these little icons is equivalent to 250,000 people. So here you have, we needed remember we had about 2 million people in our population of Republicans, and we needed about 500,000 of them here. So here I just did about 500,000, so that 250 plus 250 is 500,000. And then here I only needed about 25,000, which is probably a little smaller than what I have here. But there's a good representation. And remember, how many of these guys did we have? We had 1/10 of a million. So this particular legend is 1/10 of a million. So one of these represents 250,000. So that's about how much I got to use of it. And then here I had about 1 million Democrats. So that was 250,000, 4/4 makes a whole million. And then I needed about 250,000, and there's that little representation. So now let's look here. You guys, this was a lot of people actually polling a half a million, 25,000, a quarter of a million people. That's a lot. What if I didn't have that much time and money for the resources to pull all those people and enter all that data? Then maybe I would, instead of 25% of the population, I might pull 0.025%. And remember, you guys, if I took that percent sign off, I would have to include two more zeros there. So, whoops. So please remember that 0.00025 is equivalent to our 0.25%. And this will come into play when we do our Excel. So now, is it more reasonable to say that I could pull 500 Republicans, 25 independents, and 255 Democrats? Yes, it's much more feasible. All right, guys, very good. Now let's look at our last piece here, and that is going to be our cluster sampling. Well, cluster sampling is very similar to stratified sampling, kind of. There are differences, of course, I'm about to show you that. But I didn't mean that they're very similar. What I meant to say is they're easily confused. And I'm telling you that from personal experience. So I found a way that I think I can explain it pretty good. We're going to divide the population into clusters, and then we're going to randomly choose a cluster to take our sample from. So let's have a look. All right, in our stratified sampling, you guys remember, of course, that we separated our state into 3 different sections: Republican, Independent, and Democrat. When we're doing our cluster sampling, what we're doing is we're trying to find some similar clusters. So here we go, I'll just start doing this. A similar cluster. Do you see how this cluster is diverse? I have a lot of different groups represented in that cluster. Here's another good cluster. This is a very good cluster, isn't it? Don't you think? It's very diverse. My goal right now is to diversify my clusters. So that one looks pretty good. I would really want my clusters to be, more, I would really like my clusters to be as heterogeneous as possible, meaning I want them to have as many different elements as I possibly can. So a couple of these clusters are not really representative of the state. And it's making it a little difficult, because maybe if I did these clusters, even still, you do want your clusters to have about the same distribution of diversity. Do you see what I'm saying? Now what I can do is I can label these cluster 1, 2, 3, 4, and then I can randomly choose, okay, I'm just going to sample from clusters 3 and 4, or 1 and 3. And this is how we would perform cluster sampling. We create clusters that are very similar, and then we just simply choose some of those clusters to sample. So that's cluster sampling. Our clusters, our actual clusters, have to have a high diversity of elements, and then each cluster should be about the same diversity. All right, let's have a look at some sampling methods that we would not use to project information. We would not use the sample that we collect from these particular samplings to project onto our population. So if we were taking a convenience sample, a simple like, hey, here's a question I need answered, can you answer it for me? This is not going to cut it for projecting what we learn onto the larger population. Judgmental sampling, quota sampling, or snowball sampling. I'm just going to quickly give you a quick lowdown on these. Let's just say that we want to know the average time people wake up in the morning, and we're going to the gym at 7:30 a.m. So I'm just going to ask the first 30 people who walk into the gym um, at the door on the machine I'm on at that time. So in this case, am I even going to have an idea what the average time is that people wake up if I'm only asking the first 30 people who walk in the gym at 7:30 a.m.? No, that's going to be a very biased sample. I am only going to get answers from people who are clearly up before 7:30 a.m. So the convenience sample in this particular case would not tell me anything. There are there are convenience samples. There are times that a convenience sample can give you information that would be valuable to your particular study or maybe a preliminary piece of a study you're trying to do. All right, what about a judgmental sample? Suppose you want to study muscle reaction of the average person who works out 4 or more days a week before 7:30 a.m. Well, here I'm actually getting data from somebody who would know about the reaction time of a person who works out 4 days a week before 7:30 a.m. So I'm actually taking a sample of a group of people who can give me a good judgment on this particular scenario. So a judgment sample, I also saw some other stuff that was interesting. One and a bad way to use a judgment sample is, say I wanted to prove to a teenager that people actually get up before 7:30 a.m. So in this case, I might go to these people who know about getting up before 7:30 a.m. and ask them some questions about how it makes them feel. Are there benefits of getting up before 7:30 a.m.? And then I would take that data from those people who know back and give it to my teenager and say, look, people do feel better and get more done when they wake up before 7:30. So a judgment survey could be used in all kinds of different ways. What about a quota survey? Well, if we want to know the favorite drink of people who go to the gym at 7:30 a.m., we would be meeting some sort of quota. If I have a vending machine, a drink machine there at the gym, maybe I want to know what are the best, and say I noticed that most of the drinks are gone before 10 a.m. So, and I fill the machine up, at the end of the night. So I know somewhere at that time, the most drinks are getting chosen. So, in order to fulfill the amount of drinks I want to sell out of that machine, I'm going to find out from this particular group of people, what do you want? So, a quota sample. And now a snowballing sample. Well, in this case, say I found out what sort of drinks they like. Now I want to know, what about those drinks you like so much? How do they make you feel? So now I'm not only a vending machine owner, but now I only want to put drinks in there that make my customers feel fantastic. So I'm going to take the data that I learned from what their favorite drinks were and find out how those drinks make them feel. So this question actually snowballed over from which drinks they liked. All right, so all of this information here, our convenience, our judgment, quota, and snowballing samples cannot be used to project information onto the larger population. And I just thought this was kind of a relevant little cartoon. This girl's doing a survey. Obviously, she did not read her bias um, sampling techniques, and she's at the dog show asking a prize dog owner if she prefers dogs or cats. So here's a bias survey. She's not going to really get the best results there, is she? We have other ways for bias, types of bias. A response, it can, in a survey that influences the response. Like for example, doesn't working out in the morning make you feel great? Well, that is going to stimulate people to think that working out in the morning makes them feel great. If I only ask people to respond to my survey, how does working out in the morning make you feel? Well, the only volunteers I'm going to get are likely people who want to tell me how great they feel from working out in the morning, or maybe just only from people who want to tell me how they would never get up to work out in the morning. So volunteer responses are not going to get me a reading of the population. And we've already talked about convenience. And then, of course, our under coverage is very important because, again, what if I were back up here in Arkansas asking about our queer rights? If I was only going to ask these folks in the Midwestern part of the state how they feel about queer rights, well, the reading that I would get would not represent all of these other parts, these other folks in Arkansas. So we do want to always be extremely careful about representing the entire population. All right, guys, we are ready to explore some data samples, calculate some probability, use spreadsheets, and discuss bias. So let's get to it. On our scenario 5, our first part of the instructions sends us to a website to look at the newest trends in the percents of Republican, Independent, and Democratic voters. And then we're told to create a table and a pie chart to show the percentages of Americans in those particular categories. So let's go ahead and look at that. Going to this very first website, we see that we are here at party affiliations, and we are asked to um, create a table and a pie chart showing the percentages for each party. Well, the latest trends, folks, the latest trends are right here, this first row. This is all you are interested in. Today, I have for March 1st through the 10th. By the time you do this, you may have a whole nother row here, so you'll be sure to collect the latest trends, okay? So make sure that you guys have that. Those are the only 3 numbers you need from this website. So now I'm going to go to my Excel, and here on my Excel, I have gotten ahead of myself because I went ahead and set this up a little bit before you guys showed up here today. And I only need this piece right here for this particular thing I'm doing. All I'm doing right now is I've grabbed the Republican, Independent, Democrat percentages. Now you guys are going to see I have different percentages here. I just used any numbers. I made them somewhat close, but you're going to use your own numbers. I will not be using any of the same numbers for this piece. All right, so you guys are just going to select this data here. Let me make this big. You have created this little chart, you've put your data in, you select it, you insert a pie chart. It's that simple. Please make sure that your pie chart is correctly named. Percentage is not the correct name for this pie chart. This pie chart is United States Poll Political Party. Of course, you can come up with something better. That's just whatever I thought of at that moment. So now I've named my chart. I am also going to add some data labels. You guys, a few of you are finding out that you lose quite a lot of points for not including your data labels. The way this looks is not acceptable. You guys have to make sure that everything is aesthetically easy and clear to read, because that's the point of all this, is making our data easy to interpret at a glance. All right, so make sure your stuff is aesthetically pleasing. That is part of this class. All right, let's move on to the next part of the instructions here. The next part of the instructions send us to another web page and simply tells us to collect the population data. So this next web page takes us to the census population reportings, and you can see this is an awesome website if you guys want to take a few minutes to look through it. The only thing we are interested in here is the US population. Everything else is just for fun. So look how it's in real time as much as it possibly can be. We get our birth rate and our death rates per second. So, and way more cool stuff. So you guys take a look at that. Spend a couple minutes thumbing through there if you have time. All right. So what we want from there is simply, like I said, this US population. I have entered a different value. I'm just entering my own stuff. I just held the 7 key down because that was right where my finger landed. All right, so, and if that's random or not, I'm not sure. They say humans are incapable of creating randomness. I don't know if that's true or not true. I feel like I randomly put my finger on the 7. All right, so here you have the US population. And I want to know the number of Americans because it says here to collect the current US population, add a row to your chart for the number of Americans projected. So here we have for the number of Americans projected, and I can even put a little highlight on that. And that means number of Americans. Well, I have well, let me make this big for you guys. I'm really trying on that, just so you know, if you haven't noticed. Um, my number of Americans equals 25% of my population. All right, very good. Now I want to do, for my independence, I want 40% of, remember the word of means multiply. That's why I say it all like of, 40% of my population. And then here I have 35% of my population. And then again, 5% of, whoops, 5% of my population. All right, now I have my actual numbers. And that's all I needed from that particular piece for the population. Now, I am going to continue using this population data throughout this entire scenario. So that was just the first time that I used it. All right, cool. What's next? Look how far down the line we are. Now we're going to go to this next surveymonkey.com and we're going to look for current approval by party ID. So now we want to know how many Republicans, Independents, and Democrats approve of our current president, President Trump. So let's go to the next web page and we are going to see Trump approval ratings. So here we have, all right, I couldn't get the highlight off this web page. All right, so here we have all kinds of information. So what do I want you guys to do here is scroll through this web page and read every word. It's real hard to find the data, but I want you to figure out what the president's approval ratings are for Republicans, Independents, and Democrats. You have to really read every single word. Just kidding. Just scroll down a bit here and you will come to this particular graph, current approval rating by party ID. Now, it's not as complicated as I just pretended it was, but it is not just as easy as collecting the data because what we have to do here, let's see how big I can, well, that's not bad. All right. Now I have to create, let's go back to our instructions really quick. It says to go to this web page, collect the data for the current approval by party ID, create one table and one pie chart for each party with columns for percent and president. All right, so let's look at this. All right, so here I have 3 tables. One table for my Republicans, one table for my independents, and then a table for the Democrats. So you guys are going to take each of these tables and create a pie chart for each of them. I am only going to do this first one with you. You guys will do the rest of these on your own. The approval rating for President Trump by Republicans, look at my chart over here. This chart gives me these bars, and it tells me that if you can see colors, the green bar, the first bar, 55% strongly approve. The second bar, 32% somewhat approve, 7% somewhat disapprove, and 5% strongly disapprove. Well, that means for the sake of my particular data collection, I'm not getting that specific. Sorry if I'm making you dizzy here, but when I'm making it smaller and bigger, it's changing things. All right, so here I have my approval. I only care if they approved or not. So my approval rating here is 0.55 because 55% is 0.55 plus 0.32. So that gives me a grand total of 87% of Republicans approve of President Trump. And then I have 7%. Well, what is 7%? 0.7? Is that right? 0.7 is 7%? No, it's 0.07. Don't forget. 0.07 plus 0.05 disapprove. So 12% disapprove. And then how many Republicans gave us no data at all? Well, in this case, I had all the 100% of Republicans. So that's one, right? Just one, because if I'll just do it real quick in this blank cell. If I put a 1 in this cell, and then I go up here to my numbers and I click on percent, whoops, you can just have a single click. If I click on percent for that, it turns 1 to 100% because one whole of something is 100% of that thing. So here I just do 1 minus the sum. Remember, sum just means to add stuff up. 1 minus the sum of those two numbers. That is going to give me the percentage of the Republicans who did not give any data, which was only 1%. All right, so now I want to know how many Americans are there here. Well, the number of Americans here are, I have to have it this small so I can reach both sets of data, are 87% of the number of people in America. Are the number of Americans. You see, this one says percent of Republicans, but this is number of Americans. Well, that's 87% of Republicans. So does that give us the number of Americans? No, it does not. So in this case, rather than the number, I cannot use the Americans here, I have to use the number of Republicans, the number of American Republicans. So you guys be careful on that. All right, now I want 12% of Republicans. Well, that is 12% of Republicans. And then again, and you guys, really, you could have actually just locked in this E cell here. If you just locked in this E cell, then you would be able to just drag this down or just double click. All right, very good. Now what you're asked to do is create, let's get back here to our page. It says to create a pie chart, one table and one pie chart for each party with columns for president approval and disapproval. All right, so now I am simply going to select my little set of data here. And we can just use percentages. Is it going to let me do this? Oh, it won't let me use it, the top one. I can just do that. Percentages, and here is my lovely little pie chart. And of course, you guys can get cool if you want to get cool. I like cool. All right, just don't forget your data labels. All right, very good, you guys. So you are going to create a pie chart and a table for each of those sets of data. Now, let's see what's next. The next piece of our instructions, where did we go here? The next piece of our instructions says to create a column to show how to use Excel to randomly choose 25 voters. All right, let's get over here and do this. We are going to create this column. You guys can see that I have created a column that says random sample of 25 voters. And so what we're going to do here, let's see how big I can have this and have everything in here that we need. All right, I'm going to pretend that every single voter has a number on them from 1 to whatever they are. however many there are. I'm not going to worry about the unknown voters at this time. I just want to know how many Republicans, Independents, and Democrats there are. And those are going to be all of the people who are going to get picked for my random sample. So in my random sample cell, I am going to type RAND, and nothing happened because I don't have my equal sign going here. Let's see. I can do better than this for you guys. So I'm going to type in RAND, but I have to put an equal sign first. Sorry, here. Equals. Now, you see where it says I can choose a random number, and we did that with our dice throwing, but now we're going to choose a random number between two numbers. So double click that one, and you want your random numbers to be between 1 through, so you put a comma, the sum, double click on sum, of the adding up Republicans, Independent, and Democrats. I'm not going to do my unknown here. And this is just to show you guys how to use this function. So now I have the sum, random number between 1 and the sum of whatever all this stuff is added up. I close my second parenthesis and hit enter. All right, now what's going to happen here is Excel is going to create me random numbers between 1 and whatever that number is. And I need 25 of them. So I'm just going to drag this down 25 cells, and I've already created a little chart there. Now, what has happened? Why are these numbers doing this? Well, they're doing that because hopefully you guys were yelling at me before I did that. I did not lock this cell in. I did not lock this in. So my random number generator is going down as I went down to keep the proximity. And we know better than that, don't we, guys? So I am just going to lock each of these in. In my case, I'm locking in Echo and Golf. You guys would lock in whichever letters correspond to your numbers that you summed up there. All right, guys, there we have it. Now we want to do, that's just how to choose a random sample of these voters. Of course, a random sample of 25 out of that huge number of voters would mean absolutely nothing, nothing that we could project onto the population. But I just wanted to show you how to create random sampling. Now let's try a stratified sampling. Let's pretend that we want to collect data on 0.0002% of each of these categories. So if I want to do a stratified sample, how many Republicans would I have to poll in order to get a good sample of Americans? Well, I would have to pull 0.0002% is 0.000, two more zeros, 002 times the number of Republicans. Easy enough. All right, now I can simply just drag this all the way down here. It's not going to give me what I need right away, but I work smart, not hard. And now my Echo 17 simply changes to Foxtrot 17. Oh, that's not right because these are not in the same order. I had a little error there. You guys can put yours in the same order, or you can put it in my order, either way. All right, so my number of independents was Foxtrot. And then I just did one for the unknown, just because. The unknown here was hotel. All right, so now I know if I want to take a poll of 0.002% of the population, I'll have to poll almost 4,000 Republicans, over 5,000 Democrats, over 6,000 independents, and 700 something unknowns if I wanted to get a good reading of the American population using a stratified sampling method. All right, you guys, we are really rocking it. This is actually everything that we had. Oh, except one little thing. And that is, I just had put in over here volunteering and convenience. guys, if I asked for volunteers to answer my survey about important issues, for example, environmental issues, and the only people who are going to answer my survey are either people who really want to make a difference in the environment, or people who really think that we should not care about the environment. So getting volunteers is a dangerous way to collect data, and also a convenience sampling. If you're at a, you know, wherever you are, you can collect a convenience sample that can give you a completely different reading from one group to the next. So really be careful when you're reading data and statistics. Make sure you know where the sample came from. Did they collect enough uh, entries, to make a projection? Make sure you know. That's what all this is about. You guys learning how to pay attention to information, where it comes from. All right, here we are, the second part of this scenario 5. I'm really looking forward to scenario 6. It's fun, easy, it goes fast, and like I said, it's fun. Some of you will spend too much time on it because it's so fun. So let's get this one over with. All right, so now and this is fun too. Let's look at some populations and sampling of US military. The first thing we're going to do is go to this website. Guys, there is a website listed here. It's double listed. It's the exact same website listed twice, just because I had it listed once and people asked a lot of questions. So there it is, same exact website listed twice. And that website looks like this. And we are going to gather some data about the US military. So the first thing we're looking at here is we're going to create a table with columns for the Army, Navy, Marines, Air Force, and the total number of people. And that looks like this. You guys already just got a little quick glance at that. The information that I have here is not the information you're going to use. The information you're going to use is going to come from this website that we're looking at, which is right here. All right, so the first chart we're looking for is the population of the military. So here we have this is 2016 data. We're looking for the number of people in the Army, Navy, Air Force, and Marines. So you guys are going to record the appropriate numbers into this row, not the numbers that I have. And then once we do that, we're going to go down and look for the percentage of women. We are going to just follow this chart down until you see the correct chart, which is right here, 2016 active component female representation by service. And I did mark that in italices and bold. So it's bold and it's italics so that you guys can easily find the name of that. And here you guys are going to see, again, our data is not given to us in just some very simple form. We actually have it separated into Army officers and Army enlisted. So 18% of females, 18% of the women in the Army are officers, and 14% of the women in the Army are enlisted. And for those of you who don't know, an officer is somebody in the Army with a college degree, and an enlisted is somebody in the Army without a college degree, usually. You may find some folks in the military, usually a higher rank, a sergeant first class or a master sergeant, that might have a college degree but did not go green to gold and change their rank from enlisted to officer. But all officers have a college degree as far as I know. Of course, I'm just going by my own experience. I'm not an expert. All right, but what I can tell you, I am an expert on math. So I can tell you that if we add together 18% plus 14%, I will get the total number, the total percentage of women in the military. I did go ahead and put the number somewhat the same in here. I just subtracted 0.06 just to get a little bit different reading. But you guys can see if you add together your 18 plus your 14%. And then for the next one, for the Navy, I had my 18% plus my 19%. And for my Marines, again, and my Air Force. All right, I do not have any data listed for the percent for the percentage yet of total women in the military. I would have to wait. I'm going to actually wait on that because this data is not going to give me the percentage, the total percentage of women in the military. This is just the percentage for each branch. So make sure you know that. Now, how about the number of women? Well, I don't have a chart that I could find on this. I think I'm done with this web page as far as I remember. We'll come back to it if we need to. But let's fill in the rest of this information. And on the I'm just going to go along with everything. Each of these steps is listed here of everything I'm about to do. So I'm about to do all of this right here. Okay, so you guys can read that. So here I have 26% of all the people in the Army are women. So in that case, I have 26% of all those people. All right, and then I am simply going to drag this cell all the way over. The proximities line up. Here I get 43% of the people in the Navy, 11.5% of the Marines, and here I get all of my data. This number this is not that number. This number is different. This is going to be my total column. As a matter of fact, I'll go ahead and paint that yellow. This is my total for everything. So now I am going to take, I can't do that with my percents. I can't total up my percents, you guys, because these are percents of each branch. So here I can total up the number of women. So select all those and hit your sum button. Now my percentage is going to be the percent of women in all the military is going to be the number of women in the military divided by the total number of people in the military. All right, now what percent of men? Well, I am going to actually skip the percent of men for now, although I could do what? I could do equals 100% minus 26%, but I'm going to do something different. Instead, I'm going to do equals the total number of people in the military minus the total number of women in the military. And then I'm going to just drag this across. Then I am going to drag all of that and collect the sum of all the men. Now for my percentage of men, I am going to put equals the number of men in the one particular branch divided by all the people in that branch. And then I am going to drag this over. And you guys are going to notice I have already gone ahead and selected all of my cells and put in percentage and everything because I've already done this. You guys know I have the whole thing finished. So all of my percents and all that stuff are already in here. And now that we're this far along in the class, I just expect you guys to be able to do it. All right, for the percentage of men in the total military, I have to use my total men divided by all of the military people. All right, now I have this data that I need. The next thing I'm going to do, I have actually now completed all of this whole part that all of that stuff says to do. Now I'm going to create some 3D charts to show the percentage of men and women. So you guys can see right here, it says a 3D chart to show the percentage of men and women, and then create a 3D chart, 100% stacked column chart. All right, so I'm going to do those two things. My stacked column chart is going to show the number, and my 3D column chart is going to show the percentage. So let's see what that looks like. I am not going to include the total in my charts. I'm going to make this a little bit small again so we can see everything that we're doing. I am going to select my titles because I need those for my chart. Take my finger off my mouse, nothing's touching right now. Hold down my control button and select the percent of women. Don't go too far, we do not want the total. Hold down my control, select the percent of men. Control C to, oh, I did not need to control C, sorry. Insert a 3D column chart. And there we have it. Very good. All right, and of course, you guys are going to label and title and add axes, titles. Please get everything on there. All right, my next task was to do the same thing, but now instead of percent, I want the actual numbers. And this time I am going to insert a 3D stacked. Looks like this. All right, so now you guys have two different types of charts. One shows you the percentages of your people, and the next shows you the percentages of your military, men and women, and the next one shows you the actual count of your men and women. All right, I lost my wording for just a second because I kind of realized I put the wrong graph in. So I'm going to delete this chart, and you guys can actually do this. Just hit backspace a couple times. All your data will still be selected, and then insert. It was supposed to be 100% stacked chart. See how that one has the numbers? This one gives me my percentages. Sorry about that. All right, there we go. So now you guys have these two charts that show all of your data. Now I have completed all of this. I am now on this next part where I am going to create a separate table to show each of the following decimals to the nearest percentage and to the 10th. Okay, let's look at this for just a second. We have the probability that an individual was a military woman given they were not in the Army. All right, so this is called conditional probability, all different ways to look at conditional probability. Given they were not in the Army, that's my condition. The condition is that this woman is not in the Army. Okay, it's a military woman and she's not in the Army. So let's see what that means. That means that I am going to take all of the people who are not in the Army, that all of the military people who are not in the Army, and that's going to be my denominator. And then all of the women that are in the military is going to be my numerator. So I'm looking for a military woman who is not in the Army. Okay, so let's see here. And there may have been a way to word that better. A military woman given they were in the military but not in the Army. Let's change that real quick. Okay, and you have to be careful of wording. Even this little wording, I know you guys knew what I meant, but you should always be aware of how wording can make a difference. Okay, so what we're going to do now is we are going to check all of the women. So here are our women, the number of women in the military, divided by all of the people in the military who are not in the Army. Well, there are a lot of ways I can do that. I could take the total number of people and subtract out the number of people that are in the Army, right? I could do that. And that gives me a 56% chance. So that means if I took all the people that were in the military, except the Army people, and put them in a pile, what's the probability of choosing a female? Well, it looks like it's about a 56% chance of choosing a female. That seems pretty high, doesn't it? What if I did this a different way? What if my denominator were going to be the sum of all of the people in the Navy, Marines, and Air Force? Is that the same thing as all the people minus the Army? Yes, it is. So you guys can do that two different ways. All right, so if I took all the people in the Air Force, the Marines, and the Navy, put them in a big pile, what's the chance that I picked a woman who was not in the Army? All right, so that's my probability there, 56%. Okay, so let's have a look at this second part where we are going to create a separate table to show each of the following. The first thing that we're going to look at here is the probability that an individual was a military woman given she were in the military but not in the Army. All right, so when we say given, this word right here, given that she was in the military but not in the army, that's our condition. So that means that I can only consider the people who meet my condition. I cannot go outside that condition. So here are military but not army. So that's going to be my whole entire group. And then from that group, I'm going to look at just the women. So to find the probability of taking all the military people who are not in the army and choosing a woman out of those people, what's the probability? Let's take a look. All right, so, and you can see I've used proper conditional probability notation here. This means woman given she's in the Air Force, Marines, or Navy. Because isn't the Air Force, Marines, or Navy the same thing as not Army? Yes. All right, so in that case, that's just what that means. I have a woman who, the probability of choosing a woman who's not in the Army. Simply said, but not correctly said. All right, so here I have a woman not in the military. So how do I find that? I'm sorry, a woman not in the army. I am going to get the sum, and there are multiple ways I can do this. I'm going to take the sum of all of the women who are not in the army. That's these three guys right there, all of those three. And then I am going to divide that number by the sum of all of the people who are not in the army, because that's my condition. Use parentheses here, open and close for my numerator and my denominator. And then I would have to do the same thing here. I would just take the number of all of the people in the military and subtract out the number of people in the army. And in that case, I get the same answer. So, there are other ways also. I just thought it was cool to show you two ways. Now, then you guys are going to do that number to the nearest tenth. You guys, you can't drag this over and you cannot even cut and paste it, but you can cut and paste it this way. If you open the cell completely up, control copy, enter, and then put it in there. And then, I had already selected this column and made it into a percent. And that's what you guys are going to do. And then when you're done, let's see, what do the instructions say to do anything with that? Find the probability of each. That's it. You don't need to do a graph or chart or anything for this. So the end of that, it looks like, there's 10. Yep, no graphs or charts. You guys are just going to do this for each one. Now remember, this could just get a little complicated. The denominator is, listed here. I guess I'll just do one more with you guys. So here I have the number of the probability of choosing someone in the army given that it was a man. All right, well, here are all of the men in the military, right? That's going to be my denominator. And then all of the number of people in the army. Well, how many people were in the army right here? So that's all of the army. Nope, that's wrong. All of the army men divided by all of the army. Wait, what am I doing here? All of the men, the total men, sorry. Total men for all of the branches. Oh, that's right there. Okay, so here I had the condition was that it was a man. So the divisor was all of the men, and the thing getting divided was the men in the army. Okay, so you have to be careful. Just because it says army here does not mean everybody in the army. It just means men in the army because the condition was already given that it was army. All right, I guess I'm just going to go ahead and do this with you guys because I know it can get confusing. All right, so here we have the condition is that it's a woman. So now I know that women are going to be my denominator and not a Marine. So this is going to be kind of the same thing we did up here where it was not Army. So it's going to be a woman who is not in the Marine. So in that case, it is going to be, I'm just going to use my sum function. That seems easier to me. The sum of everybody who's not a Marine, all the women that are not Marines. So that's Army. And I can just hold down my control key and click on each of these. All right, so the sum of all of the women who are not Marines divided by the total number of women in the military. All right, very good. So in other words, if I took all the women in the whole entire military and put them in one big room or one big area and randomly chose one, there's a 92% probability that they are not a Marine, which means there's only an 8% probability that they are a Marine. You see how that works? All right, last one here. In this case, oh, this is good, easy enough. All of the people in the military divided by all of the Americans. So I have to come back up here to my Americans. And I find that a very small, and when you guys do this, you're probably just going to hit 0 because I do remember that I had to add that when I did it, it looked like that. So make sure you add some more decimals. Even with 3 decimals, you still can't see anything. It's a very small percentage, 0.01% of Americans are in the military. But don't fret, that is also, that doesn't include, like, you know, a lot of people just go in for short times. So that's not all of the Americans who have ever been in the military. It's just like the current population of the military. All right, you guys, we have covered everything. So now the only thing left is for you to do your 5-sentence reports. I'm super excited to move on to scenario 6. So that was it for population and sampling. See you guys in scenario 6.